Okay, as promised, I will do one more example here that is theoretically more difficult. So let's check this out. I've got some space on the right here, and let's make some room. So what could we do here? Let's choose a new variable. Let's call it z. Let's write this a little bit more neatly. Z. Let's make it fractional. Z over 3 plus a sixth. And let's say that this is a binomial that is trapped. Let's say this is a binomial where specifically the constant is trapped. How is it trapped? Well, we are taking this binomial and we are dividing it, let's say, by 2. And on my right-hand side, let's just say I have another fraction. Let's say I have 1 over 24. All right. And the question is, how do we solve this? Well, to get rid of this constant here again, we can't just simply add a sixth to both sides because this constant is trapped in this binomial that is being divided by a monomial. So we have to get rid of the monomial first. Let's get rid of the monomial. What is the monomial? It's 2. We are dividing this whole left-hand side is being divided by 2, and to get rid of that division, we multiply. So we multiply both sides by 2. I have a 2 on the numerator and on the denominator, and they will cancel. And I almost forgot that, hey, we have to balance this equation by applying that operation equally on both sides. Now, rewrite this left-hand side, z over 3 plus 1/6. I want to make that clearly a z. Z equals 2 over 24. Can I simplify this? Absolutely, and it is very, very useful to do that because it will literally make the rest of the math more simple as well. We can see that this top number, this numerator is even, this denominator is also even, so what we can do is divide the numerator and the denominator by 2. When we do that, then we have z over 3 plus a sixth equals 2 divided by 2 is 1. That's our numerator now. 24 divided by 2 is 12. Make some room here. So now we have z over 3 plus a sixth equals a 12th. And we want to get rid of the constant, which we can now. We can just subtract a sixth from both sides. So subtracting a sixth from both sides, our left-hand side will now be just z over 3. So z over 3. I should probably write my z's with like this little middle dash just to show that it's clearly not a 2. Hopefully that's helpful visually. I don't have the plus 1/6 anymore. It got eliminated. And now I just have 1/12 minus a sixth. And I can perform this subtraction as long as we have a common denominator here. The lowest common multiple for both of these denominators is 12. How do we turn this 6 into 12? Multiply it by 2. When we do that, we can see that z over 3 is equal to a 12th minus 2 twelfths. And we can collect those numerators now under a common denominator because both denominators are the same. So z over 3 equals 1 minus 2 over 12, which is negative 1 over 12. We're almost there. We want the value of z, so we want to isolate this variable. And to get the value of z, we have to get rid of this division by 3. To get rid of a division by 3, we multiply by 3. And finally, we can, these 3's will cancel. We can see that we just have z on the left-hand side equals negative 1 times 3, multiplying these numerators. This is technically multiplying by 3 over 1. So multiplying the numerators, I have negative 3 over Multiplying the denominators, I have 12 times 1, which is 12. Is this the final answer that will get you a perfect mark? No, not final. We can simplify. Simplify. How do we simplify? Well, the top number has a factor of 3, the bottom number has a factor of 3, so divide the top and bottom by that common factor, divide by 3, divide by 3, and here we can see z is just negative 3 divided by 3 is negative 1, and 12 divided by 3 is 4. There we have our solution for z. If we want to make this equation true, z over 3 plus 1/6 divided by 2, if we want to make that equal to 1/24, well, the only value of z that would work is negative 1/4. So that's definitely a much trickier example. If you can do this example with ease, then you're in very good shape. If you can't do it easily yet, don't worry, practice makes perfect, and the more you practice equations like this, especially with fractions as well, the better you'll get.